Hi, today I'm going to show you how to make this rubber band effect. So, let's start by making a new application. We need to add two objects, one for the ball, let's rename this ball, and one for the rubber band. So let's quickly draw a ball here. And let's make this a rubber band. I'll make this a 3x2. Make it orange. I also like to put some added to alpha channels so that it's a little transparent in the middle, just for this. And you need to set the hotspot on the rubber band here. Also, I like when I make applications, I like to have this at 720 times 480, and I like to maximize it and have the background black. So let's add some values to this ball object here. It's going to use a subpixel movement. So we need XPOS, YPOS, and then XVAL and YVAL. We need gravity, and so this is for the subpixel movement in general. Then we need three other values. One is going to be elasticity. I think that's correct. And we need resist value, and we need a rubber length. So the elasticity we can put to 10 right away. We're going to make this a lower number at the start of the frame. And the resist is going to be how much of the velocity decays. So the lower the number, the faster it decays. The rubber length is going to be how far the ball can move out of position before the rubber band starts to stretch. So let's put this to 100 for now. So as I said, this elasticity need to change it. So start the frame. Let's set it to itself. Multiply this by 0.0001. And let's make the standard subpixel movement. So we want to set XPOS to its XPOS plus X velocity. We want to set YPOS to its YPOS plus YPOS to its YPOS plus y velocity and set the x position to its x bus and y position to its y bus. And we need to add the gravity to the y velocity, so let's just do this here. Y vel to its y vel plus the gravity, it's on this one, and multiply this by 0.01. So now the ball should fall. Y vel plus gravity times. Oh, I didn't add gravity. 10 gravity. So now it's falling. Okay. And let's make the rubber band stretch towards the ball, so we can have all the visual effects ready for when we start to code the actual movement, the rubber movement of the ball. So first we want to always set the rubber band to the mouse's position, and we want it to stretch towards the ball. So we'll set the x position to x mouse, y position to y mouse. We want to set the angle towards the ball. So click on the rubber band position, angle of vector, and put in the ball's position. One for maximum quality. This actually, we shouldn't use this function here. I'll show you soon why that is. And we want to set we want to scale it so that it stretches out all the way to the ball. So let's set the x scale to the distance between the rubber band and the ball. So click on position on the rubber band and distance from point. Put in the coordinates of the ball. And since the rubber band is 3 pixels wide, we need to divide this by 3, or else it will be 3 times as long as it should be. Just put in 1 for maximum quality. And if I remove the gravity so that it doesn't fall, you can see how the rubber band is jumping, so it's not always in the center of the ball, and that is because this function here, it only returns integers, and we cannot fix this by multiplying by 1.0 like we usually do. It will still only return integers. We can see this by adding a counter that shows the value of it shows the angle of the rubber band. So let's set this counter to the rubber band's angle, and you'll see that it only returns whole numbers. So instead of doing this, we have to use the atan2 method. And when you use this, you want to put in the y position of the objects that you want to change the angle of. So in this case it's the y position of the rubber band, and you want to subtract the y position of the point that you want it to point towards. So in this case it's the ball. Then you put a comma, and then you take the x position of the point you want it to look towards. So the x position of the ball, and subtract the x position of your object, that is the rubber band. And 1 for maximum quality, and this returns a float value. So as you can see, now it doesn't jump around, and you can see the counter return tells us that the angle is a float value. So this looks a lot better, but it requires a bit more, just a tiny bit, as I've learned today. But it's not noticeable, and for this you want to use the A10 method, because it looks significantly better. Okay, so now let's update the velocity of the ball. So we'll have another always event, and let's set the x velocity first. So this is quite complicated, so just do exactly like I do. Add a parentheses there, and set the x velocity of the ball plus cosine of the angle of the ball towards the mouse. So in this case we don't need to use the A10 method, because we don't really need a float value. It's not that important to have it that with such high precision. So just click on the ball position and angle of vector, and then you'll set the x position towards the x mouse and towards the y mouse here, and the parentheses, multiply this by and add parentheses, maximum value, and add parentheses of 0, or the distance from the ball towards the mouse, so x mouse and y mouse, and subtract the spring length or the rubber length, and add and the parentheses here. So this will return a positive value if the distance is greater than the rubber length, which means that the rubber will have started to stretch. So since this is a positive value, we will not multiply the x velocity by 0, or the updated x velocity by 0, so it will shift, it will increase or decrease. And move towards the mouse. But we need to multiply this by the spring constant, or else it will be way too much. Or the elasticity, and end two parentheses, and then we need to multiply this by the resist and multiply that by 0.001. So this will make all of this decay by a slight value. So copy all of this, do the same for the y velocity. Just change this to y vel and this to minus sine instead of plus cosine. And that's it. Now it will move towards the mouse in a springy effect, or a rubber band effect, like this. And then you can add some gravity to the ball to make it fall. Downwards. And as you can see, the rubber band looks more natural since it's a little transparent in the middle. Also, we should put the rubber band behind the ball. So let's just do this order: behind objects, ball, at the start of frame. And then you can play around with these values, these 4 values there. If we change the elasticity to a lower number, it will feel like the ball is heavier. As you can see, the rubber band doesn't pull in it that much. If I make it even lower, then it would seem even heavier, as you can notice. And of course, if we make the rubber length shorter, then the stretching will start earlier, or if we make it longer, like 250, we won't affect it before we're 250 pixels away from the rubber, from the ball. So just play around with these values and use this for games like I guess Worms has a similar effect when you bungee jump, or use the, what's it called, where you shoot out a rope and then you hang by it. Okay, but I hope you learned something, and I'll see you next time.